Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
Today we're speaking with Basil Richardson, who is a studio director at Bait Smart, and he leads technical design, documentation and construction for many of the firm's large-scale timber projects. In today's episode, we're talking about the 10-storey commercial office building, 25 King Street, that has just been completed in Brisbane. Bait Smart were the architects and Lendlease were the builders for this iconic project that stands now as Australia's tallest commercial office building. So in this episode, we get to discuss all the different aspects from structural engineering and the floor grids and the stability system to the fire and acoustic considerations, and most importantly, all the learnings and takeaways in the design and construction of the project. So this is littered with a lot of learnings and a lot of gold, and I hope you guys enjoy listening to Basil Richardson as much as I did speaking to him. Without any further ado, here is the interview with Basil.
I've been at Bait Smart for about the past 10 years in Australia, mostly working on commercial projects, institutional projects, and residential projects. Lately, we've started to do a lot of timber projects, which have actually taken off in the marketplace, and it's one component that we're really trying to develop more of in the overall portfolio.
One of the projects we're talking about today is 25 King Street in Brisbane. Can you start by telling us a little bit about this project?
King's a project that's been in the office for a few years now. It started out as a 10-story office building in a commercial development area that's in Brisbane Showgrounds. So it's essentially on a new street that's going through the Brisbane Showgrounds on King Street. And it aligns about in the bulk and scale of the rest of the buildings around there. And they're really looking for a point of difference that would bring it out and make it a more interesting building and more appealing in the marketplace. And that's when really the discussions for timber came about, and that's when we started to develop it as a timber building. And started looking at the potential. Everything else around there is concrete structures, is post-tension concrete, is the typical way of building in Australia. And we were looking at ways that we could be innovative and do something that was a point of difference in the market.
And I'm sure you had concrete on the drawing board at the early concept stages. And what was some of the reasons why you guys chose timber instead of traditional?
Well, timber, when we were looking at it on what we'd like to do as the building, timber was a better choice environmentally for what we're doing. When you're looking at the effect of concrete on the environment and the fact that really you're just creating a lot of carbon pollution into the atmosphere, and instead with timber you're sequestering the carbon in the building. So just the act of building the building has the ability to actually take carbon in and be carbon positive. So that was a big consideration that went into the structural considerations on the building. Other than that, there's really timber wins in a lot of fronts in terms of the livability within the office. So it had the ability to just put up the columns, the beams, the slabs, and have everything be exposed and create a very warm, open office environment. And when you're looking at offices today, you're looking at a lot of open plan offices. And a lot of the open plan offices have a lot of hard surfaces with concrete structure. But with timber, you can have it open and be warm throughout. And what we effectively did was we managed to get rid of a lot of the things that are built into a building by using a timber structure, because we didn't have to put in a ceiling. We didn't have to hang a ceiling grid throughout the space. We actually could open it up, and for a building that is a typical 4-to-4, 3,700 floor plate building, it actually feels a lot bigger because you can open up that space, and you have ceilings that are essentially 3,500 tall, which is an anomaly in the office environment. And if you look at all of our buildings are really creating a lot of hard surfaces in the office environment. And instead of creating those hard surfaces, you're creating soft surfaces and bringing nature into the building.
Fantastic. And when you're exposing the timber, you are going with a performance solution rather than the deemed to satisfy solution. So how do we expose the timber and ensure the building's fire safe as well?
Well, there's a bit of a journey going through how to make the building fire safe. Essentially, there's probably 2 or 3 factors that go into it. One is that timber itself, although it's flammable, it burns for a while before it actually affects the structural capabilities. So everything in the timber building has been overstructured. Everything has been built so that there's a char on the outside, and you think of it, when you're putting logs on a fire, it takes a long time to get through the burning of that log. This is effectively the same thing for all the columns, the slabs, the beams in the building. Although they are flammable, it'll take a long time to get through that fire. Now, this building has been designed so that it stands up independent of the sprinkler system, and that it stands up without having to rely on that to achieve its fire ratings. However, the reality is that it's a fully sprinklered building, fully sprinklered both throughout the floor plate, throughout the fire stairs, and from top to bottom. And so it's a much safer building than a typical one that could be concrete that wasn't sprinklered. Because it's really reducing that fire load completely. And bear in mind, all of this has been tested by CSIRO and has gone through a long process to make sure that everything within the building does work. So every assembly that we're putting in there, whether it's the fire dampers that are going in, the fire doors that are going in, the construction of how we're actually applying the plasterboard to the timber to make sure that it works, has been independently tested before it goes in.
Great. And I'd like to touch on also the structure. So when you chose timber, how did the grid evolve and why the grid might have evolved in certain ways, and then what structure we ended up with?
Well, it was an interesting comparison because we started out looking at it as if it was going to be a typical 12 by 9 concrete building and how that played out. And effectively, we could get a structure that worked pretty well at 12 by 9, and as a post-tension structure, anyone can build that. That's what you do as a standard commercial construction within Australia. Now, to translate that into timber, there's a few different ways that you can do it. Timber can span long, but once you span long, you get a bit deeper. So we would have had a much deeper structure than we'd have in the concrete. If you're starting to look at putting in a 12 by 9 grid, you're going to get beams that are well over 1 meter deep in a typical glulam beam. And so effectively, you'll need to increase the ceiling height of the space in order to get a clear space under the beam of 2,700. And our goal really was to get that 2,700 underneath. So what we did was we started to look at what column grids might work and what column grids might actually give us the appropriate sizes in there. And the benefit of actually putting the columns closer as well is that you end up with smaller columns and columns that feel more like joinery items rather than feeling like these big members within the space. So the next one that we looked at was somewhere around a 9 by 9 grid so that we could get a bit closer. And with a 9 by 9, you end up having beams going in 2 directions for the glulam beam. So effectively, we have a glulam structure that supports a cross-laminated timber slab. Cross-laminated timber slab is about 200 deep, and we try to keep it around there both for fire rating reasons and for structural reasons. And with the beams spanning in both directions, it's a little bit more difficult to get services through. So we decided, well, what can we do to make it a little bit tighter, a little bit better in terms of getting the services through, because we didn't want to be penetrating these timber beams all the time. So what ended up working quite well was a 9 by 6 grid. And 9 by 6 has a little magic to it because it's where the CLT itself will span 6 meters without any beams supporting it. So you can get a 220 CLT slab that just spans across beams that are running in the other direction. And also 9 meters is the dimension where you're somewhere around an 800 beam, somewhere around that in the glulam structure. And so you have effectively a timber for the CLT, which is around 200, and a beam that's around 800. You have a meter space in there, and you can work that within a typical commercial floor-to-floor height of 3,700 and end up with 2,700 clear underneath. And that's underneath the low points of the beams, and then have a 3,500 ceiling for the rest of it. So for us, that was the one that worked out the best in terms of the overall grid.
And as you said, with the 6 by 9 metre grid, with the primary beams in one direction and then the CLT in the other, you could also run the services parallel with the primary beams without the penetrations.
We could, and that was the beauty of it, was that the services By having the beams running in one direction, they could go through without penetrating, and then we had to, at the perimeter and near the core, we had to go with a shallower beam system, so we ran our columns a little bit tighter in those zones so we could make our surfaces work.
And inevitably, when you do have penetrations, is there any typical kind of detailing you need to do with the glulam beams for the penetrations?
The glulam effectively, if you design it so that you have about the middle third of the members removed for the penetrations, you're doing pretty well. The small penetrations really aren't much of a concern, but it's the larger duct runs that are going through that we tried to avoid going through. The more difficult aspect of it was just the coordination beforehand, because with a timber building, you're trying to coordinate all of these things before the timber shows up on site. You don't really want to be cutting out your penetrations with a chainsaw once the timber shows up. So it's really having a lot of your services coordinated at the initial stage or the early stages of design, and figuring out the final solution for what your duct sizes are, what your fire penetrations are, what your fire dampers are. Having all of that information documented before you're actually ordering your structure.
Can you tell us about how the stability system works in terms of the core and the bracing and so forth?
Sure. The interesting thing about 25 King, it's unusual because most timber structures that go high stick with a concrete core. In 25 King, it was a conscious decision early on that we were going to make this timber all the way up. Now, it's one of the things I like to talk about in timber buildings is that the construction now is very similar to how we've done previously, where it's all about having a solid and impervious base with timber up above that's then protected from the elements by a separate material on the outside. There's not a lot of timber on the outside of this project that's exposed. And in the old days, you would have used a tile roof, or you would have used some separate cladding, which was sacrificial on the outside. In our case, we're using a curtain wall system. But at the same time, it's still all the same principles that go into putting the timber up. With our core, we're using that as a timber core, but we're not actually cross-bracing the building with it. And so we do have separate cross-bracing on all of the other elevations, and we've pushed those out to the facade so that you can see those from the outside and really tried to highlight those elements so it's actually used as a more visually interesting structure from the outside.
So we've touched on a few the technical details about the project. In terms of construction, how has it gone in construction, and what the speed of construction been like compared to, say, what you'd see with a traditional build?
Well, it's been very interesting to see how it's gone, because this was our first large-scale timber project, and for us it was something where we probably learned more on this project than we've learned on other projects. But in the end, I think that everything's gone pretty smoothly. It's been pretty seamless. The main thing that we learned out of it is that coordination, which we would typically be doing with a contractor at the later stages, is done earlier with the contractor, or even before the contractor is involved just with the consultant team. Often it occurs once you have the contractors on site. So there's no going around and putting in a penetration in the concrete before it's being poured. All of that's coordinated beforehand, and it's done in the factory when the timber itself is manufactured. So there ends up being a process that's more like designing a piece of furniture. So it's kind of what you have on site is you show up with something that was almost manufactured by IKEA, and they come together and have specific instructions on how to put it together. And we're making those instructions for them as we go along. So we're doing the part where we're doing all of the penetrations and the coordination of those services, and then there's a separate component where the structural engineer comes through and designs all of the connection details that they go through. And collectively, we create this piece of furniture from the design of the original to the assembly of it. When you're normally dealing with consultants at an early stage, you're more developing an intent for the project rather than the final finished project. And the intent for the project it gives some flexibility for people later on in the process to come in and substitute things in and out. Now, with the actual design of this as a built object, you're really defining all of the elements that are going within. Now, the benefit of that is that you may spend more time designing beforehand, but the site assembly goes incredibly quickly. So you only have 6 or 7 people on site with cordless drills that are walking around and having these planks that come down and screwing them all together. And once they get it for those first couple of levels, it just flies by, and the whole structure goes up in a matter of a few weeks. So with a 10-story building being assembled in a matter of weeks, it's actually a pretty impressive process.
Yeah, absolutely. And have you had the opportunity to chat with some of the workers on site, and what do they think about working on a timber building?
Well, they think it's great because it's quieter. You don't have all of the form workers there. You don't have this army of workers that are moving about site, making a mess. And if you go onto a timber construction site, it's actually very clean and can just be swept up with a broom. You don't have all of the endless supports for your formwork going up there, and people constantly propping up and pulling down and not being able to do work on the site once the structure goes in. Instead, you have the structure going in and the services or the facade coming in the next week. So with the timber structure, once the floor plate was complete, the facade guys were installing their panels literally the following week afterwards, and it just went floor by floor up the building that way.
So it's the world's tallest commercial office building. It's a massive leap for timber construction. What are some of the lessons that you've learnt in taking this big leap in innovation if people are looking to do the same kind of project?
Well, I think some of the lessons is just working with the efficiencies of timber. We're very familiar with the inherent efficiencies in concrete and what works well. And what you need to do is assess your initial planning and your constraints within timber, and to determine just what works best for you. We determined what worked best for this project, and it's like any project. You need to take that initial step and determine how it will most effectively serve your project. Timber for an office building is much different than timber for residential or timber for a retail environment. You really, in an office building, you have the freedom of having a full open space and having everything supported by columns. Projects that we're doing that are residential more have the CLT that are acting as the walls and the floor slab, so that you have an integration between the two of those, but it's a much different structural system.
And is the acoustic requirements different as well for an office building compared to an apartment building?
They are different. So with an office, we probably have a little bit of a higher level of flexibility, I should say, not a higher acoustic requirements. But with residential, you really worry a bit more about the impact on noise floor to floor, and you need to have something that mitigates that a bit more. Whereas the benefit of commercial is that you can really expose everything. You really have the ability to have just a lesser layer on the top and live with a bit more noise that's common in an office environment.
And what other projects are on the table now for Bates Smart, and is there anything we can announce that's upcoming in the future?
Well, we actually have a few timber projects going on. It's something that the whole industry is very excited about at the moment. We are looking at doing another project that's in Melbourne and South Bank in Melbourne, and it's a hotel project which is using timber, and it's quite different in that project because that's using timber as the structure, and that's using timber solely for the benefit of building above an existing building, and not just for the timber look. So there would be very little exposed timber within that. But a hotel actually works quite well in timber because with the smaller modules and using CLT walls, you can have every wall be a load-bearing wall that supports the structure and also provides the cross bracing that you need. So for that project, for very different reasons than using it for 25 King, timber was the obvious solution. Now, we also have another commercial building that's starting in Canberra where we're developing something that's very similar to what we're doing on 25 King Street, but on a little bit smaller scale, on the 5 to 6 story scale. And the Australian building codes have recently changed, so anything under 25 meters is already a deemed to comply timber building, and you don't need to have the same fire engineering associated with it. So for that size structure, it actually works very well in promoting timber because it's very comparable in cost to concrete and steel construction at that point, and you don't need to go through as much of the testing as you do for the larger structure.
In that interview, Basil mentioned how the warmth of exposed timber and the psychological benefits associated with it was one of the big reasons that they went with timber in the first place. Recently, there's been extensive research by Pollinate that actually quantifies these benefits of higher wellbeing and productivity. Links to this report can be found in the show notes.